in the sense of a real number. Let us do more. How about x squared plus, let's see here, 5x plus 6. So what do you guys think I should do here? Do the normal factoring. So you've seen through my chicanery. So that's x plus 2 times x plus 3, right? We don't need completing the square for this one. But what if we had? See, then completing the square gets a little bit more annoying because we have fractions that we have to deal with. And that means I have to subtract 25 over 4. See, because 5 halves squared is 25 fourths. So that is the same as this right here. I have to add 6. And then I would encourage you to make a common denominator if you're going to do it this way. How many fourths is 6? 6 is what? If you have $6, how many quarters you got? 24, right? So this is minus 25 plus 24, just minus 1/4, right? Actually, because this plus that gives me minus 1/4, which is better if you look at it as minus 1/2 squared. And then, so completing the we have difference of squares. So this is x plus 5 halves minus 1/2, x plus 5 halves plus 1/2. What's 5 halves minus 1/2? 4. 4 halves is what? 2. So we get x plus 2. What's 5 halves plus 1/2? It's 6 halves, right? What's 6 halves? 3. So my point to you is if for some reason your brain froze up, right? And you, for whatever reason, couldn't see that x squared plus 5x plus 6 is x plus 2 times x plus 3. If you were confident in your ability to do completing the square, and you could do some basic arithmetic with fractions, but you have a calculator, so you can do it, right? Calculator that. Then you could derive this like that. What is the difference between completing the square and factoring, by the way? There's a very significant difference, and I don't understand why this is not emphasized more. Factoring requires educated guessing. It's actually much more clever. Completing the square does not require guessing. It is a straightforward, you do this, you do this, you do that. There's no guessing. It's actually much less clever. But it's much easier when my coefficient is even, right? So x squared, like plus 8x, plus, I don't know, seven. Let's try this one. Now, Brandon will see me. Brianna, you'll see me coming a mile away, and you'll factor that immediately. What is it? X plus 7, x plus 1. Perfect. Great. What if for some reason you didn't see that? How would completing the square solve this problem? We do what? We have to subtract how much? 16. What is that? So we got x plus 4. Well, what's minus 16 plus 7? It's what?
9.
Minus 9, right? But 9 is what? It's 3 squared, right? So that's minus 3 squared. And now we have difference of squares. Remember, it always goes back to difference of squares. So we do x plus 4 minus 3 times x plus 4 plus 3, which of course is what Brianna told me to start with her clever method of guessing, which we usually just call factoring, right? There was no guessing with completing the square, though. We pick the middle coefficient, divide by 2, subtract the appropriate square, and off to the races. If you believe in that sort of thing. Let's see here. We still have 2 minutes, yeah. Look at another example. Actually, I think I started like 3 minutes late, so we have like 5 minutes left, right? I don't want to make everybody late for practice. I'll get in trouble. Let's see here, x squared. You got to have your priorities, right? So your x squared plus 4x plus 5, right? This is one of my favorite examples. So we do x plus 2 squared minus what? Okay. Mm-hmm. So whenever we complete the square, if you complete the square and get plus positive number, like above, then polynomial is prime. You can't factor it further. So that's it. Of course, you could also check the discriminant, right? What's the discriminant here? See here, a equals 1, b equals 4, right? C equals 5. So b squared minus 4ac is what? 16 minus 4 times 1 times 5. 16 minus 20 is minus 4, less than 0. That says that it cannot be factored over the reals. It also says the corresponding quadratic equation only has complex solutions. So this is good. I mean, if everybody understands this, then that means we can end the course earlier, because I was going to teach this to you at the very end. But I just couldn't, in good conscience, leave it out here, because I feel like the story of factoring has this giant elephant sitting in the room, like, and not asking the question, when can we do it? And so completing the square answers it. So, yeah, thanks.